Welcome! We are live. Welcome to TypeScript Berlin Meetup number 4. So while this event started in Berlin, the online format has allowed us to bring together the TypeScript community from across the globe. So I'm your host, Daniel, and today we have 3 speakers who are joining us with 3 exciting talks. The speakers are joining us from 3 continents, and in the order of the talks, we have Ethan joining us from Massachusetts in the US, Poom joining us from Bangkok, Thailand, and Simon joining us from Potsdam in Germany. So welcome everyone. And before we get started, I have a couple of announcements to make. So today we have a prize to give away. And our prize for today includes a Prisma face mask, a Prisma t-shirt, some Prisma stickers, and last but not least, we have a lifetime pro membership to Quirl. In case you're not familiar with Quirl is a task queuing solution for serverless deployments created by Simon Knott, who will also be speaking today. He's also one of the core contributors to Blitz.js. So you can check out Quirl at quirl.dev. Simon, you can probably drop the link to that in the chat. And then finally, I'd like to mention that this event is organized by Prisma, and Prisma, in case you're not familiar, is the easiest way to work with databases in Node.js and TypeScript. So the way that the quiz is going to work is that we're going to have the questions after every talk, where you'll be able to join via QR code or via the link that will also drop in the live chat. And so now, without any further delay, I'd like to invite our very first speaker, and that is Ethan Arrowood. So let me just bring Ethan onto the stage.
Hello.
Okay. Hey, welcome, Ethan.
Thanks for having me.
Let me get the names here. Is that correct? Yes. Okay, so Ethan, you are a maintainer for Fastify and an active open source contributor to Node.js. You're currently employed as a software engineer by Microsoft, based out of Cambridge in Massachusetts. And when you're not working, you can most likely be found hiking, skiing, or camping somewhere in the Northeast US. Have you been able to do that this year?
Yes, in fact, I actually am living in Vermont right now due to the pandemic. I've escaped the city of Boston and have fled to the woods.
Oh, okay. That must be lovely.
Yes.
Okay, so today you're going to be talking about advanced TypeScript definition patterns with Fastify.
Exactly. Yeah. My talk today is going to be a fun one. We're going to dive into some Fastify stuff and also doing some code sharing on TypeScript Playground. So if we're ready for it, I can share my screen and kick this off.
Yeah, let's do that.
All right. Let's see here. We're just going to share the whole screen. That'll be easiest. Cool.
All right.
And you should be able to see this now. All good. Oh, here we go. All right. Hello, everyone. Again, my name is Ethan, and today we're just going to be talking about some Fastify in TypeScript. For those of you who don't know, Fastify is a Node.js web framework, very similar to that of the likes of Express or Happy. In fact, we work alongside many maintainers from other frameworks inside of Node.js to make sure that we're all working towards a common goal of providing developers the best web framework developer experience as possible. And that's really the core to my talk today, is developer experience. Fastify itself is written entirely in JavaScript. So because of the attraction of TypeScript over the past couple of years, we recognize that Fastify should do something to help those TypeScript developers. And what that was is we went and we wrote our own type definitions. And a lot of projects do this or have community contributions through Definitely Typed. But Fastify was a bit more unique because of the way our application is built, of the way Fastify API is built, we had to do a lot more heavy lifting, so to speak. And so without further ado, let me jump into the first topic of my talk today, and that is discriminant unions and function overloads. To define what a discriminant is, it's a characteristic that enables things to be distinguished from one another. And inside of TypeScript, these discriminants can be used for type narrowing. So you've commonly seen things like a switch statement, and each case of a switch statement would correspond to some of these distinct characteristics. To give a little bit easier of an example, let's consider this fictitious union I have here called fruits. And it's made up of an apple, an orange, a strawberry, and a watermelon. The common fact for all four of these, and what makes them the ability to be like unioned, is the fact that they're all fruits. They all have that in common. Similarly, they all have a color and they all have seeds. But the apple and the strawberry are special because they are the color red. The apple and the orange and the watermelon are unique because they all have inner seeds. And the strawberry is unique because it is the only one of this union that has outer seeds. And then, of course, the orange and the watermelon are also unique in their own ways because of their color. You know, the orange is, well, orange, and the watermelon on the outside is green. And so this kind of union, while fairly trivial and fairly obvious, there is a distinct difference between each of these four entities, where if I was to ask you which one of these items is the color red and has outer seeds, you could immediately tell me which one that is. There's no ifs, ands, or buts about it. Similarly, if I asked you, what about which one of these items is the color orange? Again, there's only one option. And it's these kinds of characteristics, these unique identifiers, which are considered the discriminants. Now, there's other properties that could exist here. For example, I said that these are fruits. They have color, they have different seed orientations. So what if we threw in something like a banana? Now we've added a new color, which would be yellow. In this current example of these four fruits, there is no yellow option here, but the yellow characteristic could still be true in the sense of if we were to consider an expanded union of this sense, we would have to consider the other possibilities. But in the context of Fastify, we use discriminant unions to differentiate between HTTP servers. So let's jump into the playground link, and I actually have it already open for us. And let's make this a little bigger. So we'll start off here, where here is our union of four different HTTP servers, the four that are provided from Node.js. The basic HTTP, the HTTPS, and then the two different HTTP2 servers. For what it's worth, you would rarely use this one in production because it's, by implicitly, if you're using HTTP2, you should use it in a secure mode. But it's important that we have all four available because that is what's offered by Node.js. In our type definitions, let's start with this first interface called the Fastify instance. And this will make a little bit more sense in a moment. But here it has a single generic server extends servers. So this generic parameter server is going to be one of these four. And in this simplified example, we're just immediately passing that generic to this other property raw. In the real Fastify, there's a ton more properties. In fact, in later examples, I'll show you a couple more things the Fastify instance can do than just share what kind of HTTP server it is. But the important thing here is that the Fastify instance needs to have a specific HTTP server. And so how did we do that when we have only one entry point? Well, we use discriminant unions over the different options for this function. So the Fastify function is the one and only entry point to the Fastify API. You can see here an overload, and each one of these overloads has a generic server, which extends from one of the four different HTTP servers. it's also defaulted to that same HTTP server as well. Then on the right, you can see in this same type definition that they all share one parameter, options. And these options, though, are all different. It starts here with HTTP, then we have HTTPS, to, and then to secure. But at the end, all four loads return the same thing, a Fastify instance with that server generic. So what makes this unique? Well, if we take a peek at these type definitions here, we can see we're with the HTTP options. This is just a basic type with one optional property, logger. And very similarly, enable or disable a logger for your Fastify application. The next type is the HTTPS options. It's an intersection of the HTTP one from above, but it now has a new required property, HTTPS, which corresponds to the server options from the HTTPS library in Node.js. The next type definition is HTTP2. Consider this one the insecure HTTP2 types, where again, it's an intersection of that first baseline HTTP options object with this new property that's also required, and it's a Boolean literal for the HTTP2 property. This is how in Fastify, we enable our users to create an HTTP2 server. And then finally, we have the secure option, where again, it's that same base object, but the intersection this time has two required properties. HTTP2 is again a Boolean literal of true. And now we have that HTTPS property again, but this time pass in the HTTP2 version of the options. So with these four types here, and combined with this function overload, TypeScript is smart enough to actually infer which of the four overloads we're using based solely on whatever options object you pass to your Fastify instance. What's even more cool is that this baseline definition here, notice how the options are optional. So we can also state that if you don't provide us any options, which is a valid case in Fastify, we will assume you just want an HTTP server, which is exactly that. Because in consideration, if you want to make an HTTPS or an HTTP2 server, it's an opt-in operation. You need to provide us with the certificates and keys to make your server secure. And for HTTP2, we need to know that you want to switch to that protocol. And that's why we ask you to say, hey, let us know, are you going to want to use HTTP2 or not? So to see that, in example, we have these four constants, F1, 2, 3, and 4. And you can see how in this current one, there's no options object. And the type sense here says, hey, that's a Fastify instance with a generic of http.server. Perfect, exactly what we wanted. Same with F2. We're passing in just the HTTPS option. We're not enabling HTTP2 yet. So Fastify knows, hey, we want an HTTPS server, and so on and so forth for the other two. And we can even further exemplify this, where if you do const f1b and we say equals Fastify, and we provide that logger type here, you can see that f1b also gets that HTTP server type, because again, we're not providing HTTPS and we're not providing HTTP2. But if we were to go ahead and add that logger prop to another one of these, it would still work fine. And it still thinks it's the current server because it has that discriminant characteristics that we created in our function overload. Awesome. So now let's jump back to the presentation and move on to the next fun part of some of the things that we've done in the TypeScript definitions. This one is called named generic parameters. And most JavaScript developers should be very familiar with just named parameters in general, where if you have some function f, it takes a single argument that is some object. And then that object is structured inside of the actual functional implementation so that the user can provide the parameters for this function using named attributes rather than using some sort of argument order. And And if I can go to the TypeScript playground again, we can do a very similar thing in TypeScript as well. So here in a new TypeScript playground, I'm going to jump down to the bottom here and talk a little bit more about what we're going to sort of be walking you through. And this is also going to be brought up later in the talk as well about this whole request object. So I recommend paying attention to this part just a little bit more. Here is an example of a Fastify server where I'm using a little bit of typecasting just to sort of like pretend we're instantiating a real Fastify instance. But the point is there is these methods to create routes on Fastify, just like Express and like Happy, where the first argument's a string. And then the second argument is this route handler. And this route handler takes this first argument, the request object. And that request object contains the details of the incoming request. Things such as the query string, the body, if it was, a post or a put, the headers for basically any request, and is also parameters if that was passed into the URL. And in Fastify, we automatically figure all of that out for you. And we'll get to that. We'll get to the reason why we do that for you in a little bit. But just know that it's done for you underneath the hood. So in a JavaScript application, destructuring these four things from the request object is valid and easy to do. But those that know about runtime issues in TypeScript will immediately be thinking, okay, but like, how can we be sure that this body is of some type because it's coming from a external request? And the answer is we don't. We actually need to validate that. And we'll get to validation in a little bit, but to sort of jump ahead, we want to say, okay, if we can validate what these four things are from our request object, we should also be able to provide a type for them. And we could use typecasting like this, but typecasting can get a little messy because usually it's again, the developer has to do it. And honestly, most of the times they have to do something like this, where they're like const, and then it's like, query string 2 equals query string as, and then, some type. And that, let's just pretend it's a string here. And now the query string 2 property is this query string, but as some other type. But we've come up with a better way to do that. In the second example, you can see it's the same post request as I defined here, except it now has a generic. And in this generic, we have corresponding properties for the various aspects of our request object. And then inside of this route handler, you can see that the string type is assignable to the query string. And same with this record type that we passed here is assignable to this body. And now the way we're able to achieve that is through these named generic parameters that this whole section is about. So starting up here, we have this interface. It's called route generic. All four of these properties are optional and they're defaulted to unknown. Then we have this other interface. This interface is the request interface. That is what is corresponding to that request argument in the route handler function. You can see those types here and here. But you can see inside of this interface, we have that generic R. It extends from this route generic interface. And then inside of that interface, we're actually able to use these strings to access this interface, generic interface R. And doing so, it'll default to this unknown value because here on line 17, we're saying, hey, R extends that same route generic, but we're also defaulting it to itself, the route generic. And then that's passed down. The route handler gets that generic parameter R, which it then passes down to the Fastify request. And then at the end, Fastify request gets this generic and can apply it to these four corresponding properties. So this is one of the ways that users can also optionally set different parameters here where, for example, if they still want their headers and parameters to remain as unknown, they can do so just by omitting it. The alternative solution here is having an ordered generic, which is what most people are used to seeing, where the first one could be query string, the second body, third headers, fourth parameters. And if you have a request that only wants to specify the parameters type, you would need to then provide either some sort of default for the first three or some sort of like undefined or unknown for the first three. And that can get a little messy in your code. So it's much better that we let our users sort of opt in to the properties they want to be typed as they go. And now, some might think that this actually is not type safe. And you're right, it's not. It's not inherently type safe right now because there's nothing verifying that this query string and body here are actually what I'm saying they are. Because who knows, what if the user didn't pass in a query string to their request for this route? Now this query string might be null, but our types say it's string. So what do we do about that? Well, I encourage you to hold on to that question because I'll answer it in a little bit when we start talking about some of the advantages that come with TypeScript 4.1. So back to the presentation. I have one more little thing I want to share, and then we'll sort of go back to the ideas of this validation part of our, this dynamic aspect of our data. And this is declaration merging. This is something a lot of people are familiar with, especially those dealing with external modules. Plugin systems are hard in TypeScript, and in Fastify, everything is a plugin. I don't want to get too much into details what that means, but the point is, in this little code snippet you can see here, we're using one of my favorite plugins, Fastify Multipart. It enables the multipart request stuff, so you can send files to a Fastify API. And you can see here that this request object now gets this new file method, which is a promise, and it resolves some data object. And that data object contains a read stream under the file property, and then as well as a write stream, and then as well as has a file name as a string that can be used in a method such as a write stream for creating a write stream. In this sort of crude example, we're just sort of pumping the data that's coming in straight out into whatever the server host is. So I also have a TypeScript playground link for this, but I don't think it's as valuable because this one is really demonstrative over what would be considered a project, multiple files. And so let's start with the top left here. And this is fastify.ts. You can see we have two interfaces, request and response. The route handler and route method, which I've already shown previously, have been much more simplified for this example, where there is no more generics, and we just have the request and the response object, and this route handler is promise-based. And then that route, wraps that handler as that second argument. And then here inside of our Fastify instance, we have those our HTTP methods, get, post, put, and they all correspond to a route. And then taking a peek at our app.ts file, you can see that we're creating that server based off of what's exported from Fastify. But then inside of our request handler here, notice how we're calling request.file. But this request interface doesn't actually have that property. We have no properties in it for this example. So then how does our project know that the file method exists as well as the file property, as well as this file name property? And that's the power of declaration merging. Inside of Fastify Multipart, which you can see we're importing on line 2 of our app, is declaring this Fastify module. And we're saying inside of that Fastify module, we're going to export this type called data. And data is going to be a file as a read stream and a file name, which is a string. And the interface, Fastify request, now has a new method file that returns a promise that resolves with that data type. And you might be thinking, oh, wait, that's the same name. And that's how declaration merging works, where if you declare a module that also exists in your project, such as Fastify.ts here, TypeScript will infer that, okay, let me take all of the types defined inside of this block and merge it with all of the definitions defined in this block. And then inside of my project here, app.ts, I get both types. I get those that are defined from Fastify and those that are defined from the plugin Fastify multipart. And yes, this isn't a perfect solution, because who's to say, just because you're importing Fastify multipart, that you're actually using it? And unfortunately, I don't have a great answer for you. Plugin systems in TypeScript are really hard. And because Fastify is written in JavaScript, we're sort of limited to what we can do. If this was a TypeScript project, there might be a better API that we could develop that creates the correct encapsulation for these plugins and such. However, again, this is a JavaScript project and we're providing TypeScript definitions on top of it. So we sort of have to give and get, and we have to meet in the middle or compromise, so to speak. So great. On to the last kind of part of this talk, and that is some of the new template literal type features that are coming with 4.1, and something that I'm really excited about. So here are two tweets that I've had tracked for a while. The first one on the left is about URL parameters. In fact, it's talking about Express in this example, where using these new template literals, you could give some sort of route and then derive the information of that route just purely using type definitions. And I thought that was really cool and actually really impressive. Now, I don't know how applicable this would be in Fastify, since we sort of apply that information through our own API, but it just shows off other cool things that template literals do. On the right, though, I want to start getting everyone thinking about a JSON parser using TypeScript's type system. So this example is way too big to fit in a single slide, but if you're interested, you can go to this link here. It's a shortened TypeScript playground, and it has, it's basically this link that this tweet has, but shortened. And I want you to think about, what could the possibilities be if we could build an entire JSON parser using TypeScript definitions alone? Fastify has this concept that I mentioned before about validation and serialization. It utilizes JSON schema and JSON schema validation. Our particular library of choice is AJV, another JSON validator. And we use this validation and serialization feature to make our routes faster and more secure. And what I mean by that is, here in this example, we're providing this schema as the second argument to this route. When a schema is provided to a route in Fastify, the Fastify engine will take that schema and do two things with it. First, it'll serialize all incoming and outgoing data based on that schema. So if your schema fully covers what your route will do, Fastify is actually able to process incoming routes faster because it knows exactly what data it's going to be receiving. It doesn't have to do any sort of guessing or checking during like the runtime, so to speak. The other thing is the security, where if you are defining that your body should be of some shape, it should have some explicit properties, and those properties are required, and the body doesn't have those properties, then Fastify will actually never even run this handler. We'll just say, nope, we'll 500 server, or some 400 or 500 error, this isn't valid. We provide other mechanisms, like hooks so you could run some code if that error hits. But for the sake of simplicity, just think that if the schema doesn't pass, the route handler doesn't execute. But what about TypeScript? Remember before I showed you how we can provide types for these 4 properties for our incoming request object. And now we're validating that request object based on some schema. So how do we connect those two things together? The types of these 4 properties, as well as the schemas that we're writing for our routes. There are two existing solutions, both I've used and really enjoy using. The first one on the left is really great for projects which would have large amounts of routes and schemas, as well as a big existing tool chain. You write your schemas using just in JSON, following the JSON schema spec. And then you pass it to this CLI, JSON schema to TypeScript, and it will generate TypeScript definitions for you based on that JSON. And then you can import both of them into your route and pass the interface as the generic to your route, and then pass the corresponding schema as well. And then your 4 properties inside of here will get the types based off this route schema and will also be validated. And you actually have fairly type-safe code at runtime. It's not actually type-safe, but it's as close as we can get. On the right, here's a more interesting one. And this is a Fluent-like API. This is called Typebox. And you define your schema using this type API. It's called, you do type object, and then inside that object, you define a property, let's say body. This corresponds to the schema, the body part of our request. And then that body is also an object, and it has a property foo, which is of type string. This schema here, what's returned from type.object, is a valid JSON schema. So you can pass that right on into your request. And then your generic here can be derived directly from that object using this same library's static type analysis. So this one is also very cool. It can be used, it's very testable. It's very dry, and it helps, keep your schemas more understandable because they're written in code. They're not just JSON. So what if we took TypeScript 4.1 and that's sort of like the ability to process JSON that we've seen examples of, combine it with Fastify's existing validation part, as well as just a JSON schema spec. In theory, we could have a solution where there is no need for a generic here, where a user can just pass in their JSON data to the schema field, and the underlying type system would be able to infer all of the types from that JSON and apply it through to query string body headers and parameters. And this is one of the things that we're really excited to start experimenting on when 4.1 is released. And it's in beta, so we've already started experimenting. But of course, we're gonna, we'll wait until the major release until we actually put it into action. So that's about all I have for today. I would say if any of this has sparked an interest in you, please come and check us out on GitHub. We are a growing community and we're very welcoming. If you have never made an open source contribution before, come on in. We are more than happy to help out. We have a bunch of repositories that you can contribute to with all a very low barrier of entry. All of our source code is written in just ES6 JavaScript, and we don't use blurs, we don't use anything fancy. Some of our plugins are written in TypeScript, which is great for TypeScript developers. And of course, if you're, if you like this sort of patterns I've shown today, you can see all of that and more within the Fastify project itself. We ship all our own types, and all the type definitions I shared today are based off of the real ones inside of the Fastify project. So thank you very much. Again, my name is Ethan Arrowood, our engineer at Microsoft. I thought this GIF would be funny because we're getting close to Halloween, my favorite holiday. And feel free to reach out to me on Twitter. I love chatting about TypeScript, JavaScript, Node.js, and plenty of other things. So, all right, that's all I got. Thank you again.
Ethan, thank you so much for that. That was really insightful. And I think that also builds on a talk that we had at the previous meetup where we had, I think, Mano. He discussed some of these validation challenges with TypeScript where you're trying to essentially take runtime validation and perhaps generate types from it and vice versa. And so I think we have a really, really exciting future very soon. if we're able to get that, as you suggested, with the template literals from the JSON schema. So that's really exciting. Do you have anything, before we get to the Q&A, do you have anything else to share about Fastify? I think it's a really exciting framework, and we're seeing more and more adoption of that.
Yeah, I'd say, just to reiterate, the open source community, we have a Discord channel, we have discussions enabled, we have a help repository. So come and chat with us, ask us questions. We have our maintainer base has been growing a ton over the past year, because we're really just trying to just be this great big community of framework developers. So even if you don't use Fastify, if you're an Express or Happy, or you got your own framework, I know Prisma has done some stuff with, I think the Blitz.js folks. They're working on their own thing underneath the hood. I say, come and chat with us. We love the framework ecosystem, web frameworks. We want to see and help each other grow. So, thanks all.
That's great. Okay, so thank you all for all of the comments. We'll now take some questions. Are you ready for some questions, Ethan?
Definitely.
So if you have a question, I think it would be a good time now to drop the question in the chat. We also have an interesting comment. Thanks. Interesting to see how TypeScript syntax is becoming more and more like a language of its own to construct types. Indeed, yes. Okay, and if there are no questions, I guess the talk was crystal clear. Great. Okay, so now we will move on. So thank you so much, Ethan. And I think now we will move on to the quiz part, and I'd welcome you to stay for this part, because we're going to have questions that are based on your talk. So if you were paying attention. Okay, so I'm going to add this to the stream. And okay. And so we've had already 8 people join the quiz. If you haven't already, you can either scan the QR code, or you can join the link that I left in the comments. And you also have a third option, developers, we love our options. And so the third option would be to go to slido.com and put that code in. And so a quick reminder that the winner of this quiz, which will include questions related to the 3 talks that we have today, will win a bunch of different things. We'll win some Prisma related swag, and we also have a Quirl license. And if you missed the beginning, Quirl is a task queue manager for serverless environments. So without further delay, let's get into it. Okay, I will activate the quiz, and we have the first question. So what is a discriminant? The first choice, a similar characteristic for a set of things, the red color characteristic from the fruits example. A distinguishable characteristic for a set of things, the orange color and the inner seeds characteristics from the fruits example. And we have the third option, a general characteristic for a set of things, like the fruits characteristic from the fruits example. And lastly, a missing characteristic for a set of things, like the purple color characteristic from the fruits example. And so we have 9-10 votes coming in. Wait a couple more seconds. And let's see if I can also show the leaderboard here. Okay. All right, so we have the 12 votes in, and most of you voted B. And indeed, that was the correct answer. And so now we will move on to the second question, and that is, why is it hard to provide true type safety for root handler's request instance? And so there we have the 4 option. It isn't hard. They're already type safe and all problems have been solved for us. Second option, there exists no mechanism for safety typing at runtime. Third, a request instance is a highly dynamic object. It can have many different shapes during runtime. It can become safer through validation. And then lastly, the fourth option, you can use typecasting, thing as type, to make anything type safe. And so we already have 15 votes in. Oh, 18 votes. Okay, it's nice to see everyone joining in. So, all right, 58% voted for the third option. And let's look at the results. So indeed, the third option, the most popular one, was the correct one. And so on that note, we finish the quiz for this part and we will continue. So keep the URL or keep the page open and we will continue with that later. Ethan, once again, thank you so much for joining us and hope to see you again at a future TypeScript meetup where you might be able to share some even more exciting news about Fastify
Yeah,
and the
thank you so
TypeScript
much.
ecosystem. Thank you.
Yeah,
All right.
this has been wonderful. Have a wonderful day, everybody.
Okay, we're now moving to our second, I will get the label correct. Yeah, so we're now moving on to our third talk. And our third talk is by a speaker joining us from Bangkok in Thailand. And his name is Poom. So I'll bring Poom onto the stream and get the labels. Hey, Poom.
Hello.
Nice to meet you.
Can you hear me? Nice to meet you.
Welcome. So you're joining us from Bangkok
Yes,
in Thailand.
Yes, exactly. I'm joining from Thailand.
Great. And so I want to give a little introduction. So Poom is a developer advocate at Brickle, based in Bangkok, Thailand, and he enjoys building silly apps with React. He tinkers with cutting-edge stuff like Rust and WebAssembly, and customizes his dot files for fun. On other days, he runs community projects like the Stupid Hackathon Thailand and the Young Creators Camp to get Thai developers to keep hacking. Or he's just relaxing at an onsen bath in some corners of Bangkok. So it's nice to hear that there's onsens in Bangkok, but that's not today's topic. So today's topic for your talk is going to be why you might not need advanced types. Is that right?
Yes. Yes.
Cool. So without any further delay, you ready to share your screen?
Yes. Let's do it.
Let's do it.
All right. Can you see my screen?
Yes, we can see your screen.
Yes.
We're getting a nice effect here. Great.
Okay. Does it work?
Yep, you're live and it's all good to go.
Okay. Thank you. So I will start now. Okay, everyone. Nice to meet all of you. My name is Phoomparin Mano, and I'll be talking about why you might not need advanced types today. Okay, so my name is Poom, and I'm a developer advocate at Brickle from Bangkok, Thailand. And it's true, yeah, I like to enjoy onsen bath in Thailand. But most of all, I organize a lot of like developer community projects for like students and university students in Thailand, like Young Careers Camp for people to make their own products, and the Stupid Hackathon Thailand to encourage Thai people to like build stupid things. Yeah, and you can follow me on GitHub at Phoomparin. So let's begin now. Okay, so the story of this talk is I see a lot of developers. Most of them like they have a good grasp on TypeScript, but most of them haven't even checked out the advanced type section of TypeScript. And I'm one of those developers too. And I believe in a saying that learning in public is like really helpful when you're learning new technologies. So I'm pretty new to TypeScript to myself. And that's why I have a question. When do I need to use advanced types? So this has been a question that's running on my mind for quite some time. I don't know like when the need for conditional types or like using the advanced features will come up. So today's talk is mostly for people who haven't touched that section. So if you have already, this is like a good opportunity to like refresh the knowledge. Okay, so in my scenario, the scenario I see which is perfect for learning about advanced types is building a schema builder. Like as the last talk, like as Ethan already said, when you're having like a very dynamic object like a JSON, it can be very hard to validate or very hard to like get them to be type safe. So I think building a schema builder is going to help me learn on this. Okay, so since I'm a hackathon organizer, let's make an app for grouping people in hackathons. Yay. Yeah, so I'm the organizer of the Stupid Hackathon Thailand. And one problem we have is people in hackathons, usually they don't know like who to group with. who be the perfect team to like do the hackathons with. So let's make like an app for them. But first, let's look at the API surface. Let's look at the API that we are gonna be making a schema. So when we are organizing a hackathon, there's gonna be people joining us, right? So they're going to be a member. So this is what my API for a query builder might look like. I might have like a type function that constructs a new type, and then you can use a function like ID, text, and number in order to construct the fields. And this looks simple enough, right? Since this just scalar types, but it can get more complicated. Like in a hackathon, you might have a team, and in that team, you might have a team lead, which is a reference to a member, or you may have the list of members, which is an array of a reference to members. And this is where it gets interesting. So when you're building like something like this in TypeScript, I think pretty much the challenge here is this. So not only you have to construct like a query builder in order to construct like a JSON structure, but you also have to create a type in order for the resolver to use as well. So this is the challenge for today. Okay, so how would we write this query builder just for the types? Like we don't care about the correctness, we just need the types to be correct. And this is how I would do it. So looking at this structure, you can see this is just a pure function, like a function to construct a type, an ID, a text, a number, which is like the scalar types and the type. So I would do something like this. So I would make like a text that returns an empty string, or maybe like the number function that returns an integer. So this would give us the correct type. And if you look at this, well, it looks pretty legit. We got a type of name, which is a string, and a type of age, which is a number. So it looks already good, right? Yeah, and even for arrays of references, that's already looking quite well. So what's the problem here? The problem here actually is, well, actually when you look at the create handler function, the types here is going to be working. So it looks like it's going to be easy. But the fact is we are not done here. Yeah, we're not done because we're just constructing the types. But in order for an app to be functional, not only the type has to work, but we have to have the JSON structure for the schema. For example, it might look, well, I will show you later. But for now, let's just use like a plain JavaScript object and pure functions to construct the structure. So this would be how I would do it. So I would have like a function of type, and that would return the type of schema, a function text, and that would return the type of string, of number, and that would return the object with type of number. So while this can provide us with the structure, for example, if we construct it like this, if we compose it like this, with type of project and with text and with reference to team and so on, we would get a JSON structure that looks like this. And while this might look legit, like if we look here, well, we got the name and the type of string, we got the type of ref. So the schema here actually looks good. But the problem here is, then we are failing our second requirements. Because if you look at the types here, then everything is now any. And this is certainly not fine. So even though our JSON structure is correct, our type is completely wrong. So how would we fix this? So what we need to do is we need to not only generate the type in the code, but also in the type len. And this is what I mean. So if you create a function like this, if text returns the type of string, then the problem is that string constant is not going to be there because the type is going to be widened to string. And it's going to cause problems because then you cannot figure out if the type is a number or if it's a string. And this is a problem. But this is easily solvable. So you can just put type is a string. And then TypeScript knows not to widen that type. And it's precisely string. So this is the foundation that we will be building on. So the mission here is we will need to preserve the information in our types in order for TypeScript to be able to parse that type structure. So we are already doing a good job here. We are already putting the type, like for strings, numbers, arrays, references, and optionals. So now the structure has a correct type. And it is easy to go from here because even the schema and the name is preserved at the type level. So the information is not lost. So everything still works great, right? And if we look at the type, so if we hover over to the project constant, we can see that the type, the name, the schema is all there. So we got enough information for the TypeScript compiler to work with, which is very nice. Now, if we look at another example, so this is the schema of the team in the hackathon. You can see it has the type of string, and the team lead has the type of reference. Okay, now back to our problem at hand. The goal here is to be able to create a resolver function that gets the type that we created, and it allows us to populate it. But remember, we are not creating this type by hand. We're not creating the interface of the type, but we are auto-generating it from the constants. So how does that work? And that's our next task, actually. So we have to generate the return type from our structure. So if you remember our structure, it has a type, and then the string of what the type should be. Should it be a number, or should it be a string, or should it be an array? So let's begin from our scalar types. So the goal here is to map the type to number and type string to an actual scalar type in TypeScript. So you can do this pretty easily by creating an interface with a mapping, and you can do a type scalar and key off in order to construct a union. So now we have a union to work with, which is pretty nice. So now we just want the type field. We want to access the type in the schema. So ideally, we should be able to do something like this. So we should be able to get the schema, and then we access the type on it. So this is very similar to a function that Lodash has called map values. So it just maps the values to the type, which is pretty straightforward. So now if you look at the result, now we are getting very close. Now we're getting name of the string of string and the age of string of number. So from a structure, now we got rid of the types field and map it directly. Oh, but then again, if we were to map the type mapping to the native type, we're gonna get a problem. And why is that a problem? How did that happen? So the reason that did happen is because the TypeScript compiler didn't have enough information. So it cannot ensure that the type key is a scalar type at all. It doesn't know for sure that's a scalar. So how do we do that? And the answer here is to use conditional types. So what is a conditional type? So a conditional type, you can check if the type extends another type. For example, I can check if a type extends a scalar, for example, a string of type string and an object of type shatohu. So you probably know what this results in. Yeah, so a string is a scalar, so that's a yes. But the type shatohu is not a scalar, so that's a no. If that becomes yes, then you have a serious problem more than TypeScript. Okay, so now we got this scalar type mapping, and now we can apply it to our type field, which the type field is just a string of number or a string of string or string of array. So now we're going to get a concrete type. Great. Okay, so how about references? How do we build a reference? So let's look at our API surface first. So we use auth to construct a reference object to another type. So this is what it looks like. So you can see the type in TypeScript. It says that type is a ref, and an item, it has the structure of the reference type. So person has a type of person and the schema. And the problem now is, how do we get the item generic inside the reference? Since if we can get the item generic that's nested here, we can get access to the schema, and we can map over the schema to make it to become a concrete type, and that will solve our problems, right? So how do we do that? Luckily, with conditional types, there's another keyword called infer. So a nice thing about infer is it allows us to infer the type that is contained inside the generic. For example, if our type of ref here, we have like a nested schema, which is like from another type, we can extract that. So if we try that out to get the reference item using this given structure, then we can see that, hey, we successfully got the ID and the string. And that's pretty nice. So we can just map that. Okay, now let's put all of them together in one package. Ready? Here we go. Yeah, so this is looking like pretty Halloween-ish. This is looking a bit scary. So to most people who haven't done like TypeScript heavy before, this can look like pretty intimidating. But because like we have been here for a while, then we know that this is a conditional type. And we know that this is mapping to a scalar, which is using the type field. And we know that the ref here is just extracting the schema from inside the nested object and map that back recursively so it gets mapped into a scalar type. So that's not too bad, but we can refactor it and make it a lot better by sprinkling some comments. And let's do that. So if we sprinkling some comments in, we can see here it's a lot easier to read. So we know for sure, oh, is it a scalar type? If it is, then we just map it. If it's a constructed type with t.type, then we just recursively map it. Map it to a schema. Okay, and that's looking great. So now let's add a support for arrays. So what is an array? So in a hackathon, we may have many team members, and our query builders, a schema builder is looking like this. So we have many of member. So many is like constructing the array objects, and of is constructing a ref. And now an array can contain both a reference to another type and a scalar. So now we can just apply it recursively. For example, now we have the item, which is extracted from the array objects. So now we can see that there's an item. We can map that recursively, so it can become either a scalar or a ref, and then be mapped into a native type. So that solves our problems, and we can see it here. So if we created a structure that looks like this in the type world, type of array, which contains a reference, which contains like a schema. So when we map that recursively, we will just get like a concrete type, like a native TypeScript type, which we can use to annotate our projects. Okay, so this is how the generic map box input to return type would look like. So if we get an input, this generic can either accept an array or a reference. So first it checks if it's an array. If it is, then it maps and make it an array. Otherwise, it checks if it's a ref, and it just extracts the schema inside of it and map it again. Otherwise, yeah, just map it. Yeah, so what it does is to unbox the values in the type. And if this is your first time reading a code that looks like this, I know it can be pretty difficult to wrap your head around because like of the recursive nature and like how you usually program in code, but now you're doing it in types. And finally, we can apply this to every field inside of the schema structure. So let's take a step back and let's look at what we did. So we have this function that maps an array and a reference. And then we have another, generic. And then we have another generic, which maps the scalar type and the constructed type into a concrete type. So if we do this, and then we map it for everything in the schema, then sure enough, we are going to get a working type. So now we can see that from the type in the schema builder, we can use type of to get the schema inside of that type. And then we can just do this. We can just use that type and it will work perfectly, which is nice. And there goes our both requirements. So the first requirement is for the schema to be typed as a JSON structure. And we can solve that pretty easily by constructing an object. And second is by building the TypeScript type to use in our resolver. And that can be done pretty easily by using conditional types and recursively map types. Okay, and yeah, that's what we did. So we did it. And let's do some more practice. So we now have scalars, types, references, and arrays. So now let's create an enum in our schema builder. So this is the API that you would expect an enum to have, right? So it would like get the list of options, and then it would allow the user to just pick one. So that would be a union. But the question is how do we turn a string array into a union? That's pretty hard to do. So I know the easy way to go about this is you can use ascons. So that will turn it into like a read-only array. And then you can use type of notation here of number to turn it into a union. But there goes the problem. I don't want to use ascons in the user code. So what can we do about this? Luckily, there's another way. So you can use this. So you can use like a res operator to kind of construct the choice into an array. And then you make that a generic, which extends a string, which is precisely what we want. And this will allow us to preserve the string type. So that will not widen the type to be like an array of string, but that would preserve like the choices in our enum. So that's great. I think now the logical thing to do about this is we can just extract the choice from this generic, right? Well, not so easily. We can see a problem here, which is when we do choices and index that by number to turn it into a union, we found another problem. So if you remember back to the beginning of the talk, this is precisely the same problem. So TypeScript doesn't have enough information to ensure that it is what we want. So it doesn't know that choices is actually like a list of read-only strings. So we can hint our compiler a bit. So we can hint in the enum type, we can hint that, oh, this actually extends a string array. So this would be able to be indexed by number, and therefore it would become a union. So this is precisely what I did. And now we can use our enums as a union type. And this is pretty nice because you can just feed it like the choice like we did with the enum function, and we would just get a union out of it. So we get an auto-completion for all possible enum values without having to use ascons, which is nice. And now we're running out of time, so it's time for the final boss. So our final boss today is called optionals. So you might think, optionals? How hard can that be? Isn't that just like making like a field like not required? Okay, so let's try it out. So this is the API we want. We want our schema for the hackathon. Every team should be able to have their tagline, but that not every team has to have a tagline, right? So we would use like a box type like optional. So we would wrap the structure with optional, and that would give us the information later that we can know, oh, okay, we don't have to make that required. So what could possibly go wrong, right? Can we do this? Like we make a generic that union sit with null and undefined. So maybe that becomes like an optional, right? Well, not so fast. As it turns out, this doesn't really do anything. So both name and age is still there. It's still required and not optional. So it's not very effective. And this is why I say this is a final boss, because it's pretty difficult to deal with. So let's take a step back and look at our type. So we have a type of name which is required, and that's going to be a string. But both tagline and age is optional. So that means it shouldn't be required to include into our object. And this is just a little bonus I found. So I found that by using the new type pattern, which looks like this, you can actually create a new type in which like the value itself would still be the scalar. For example, this hello string would still have the values of the string, the properties of the string, but it's going to be interpreted as a new type. So you can use conditional types to check for that. Yeah, but that didn't really help in this case, right? So I kept on searching and I found this on Stack Overflow. So I found this nullable partial generic. And what it does is, given a list of keys, it makes them optional. So I guess the magic here is null extends T of K. I guess that's the part that handles it, but I'm not really sure. So let's get our final boss game plan ready. So here's my game plan. So first we will create a type of optional. Then we will unbox that optional. But if it's not an optional, then we default to never. And then we get the list of the optional keys. And then we use nullable partial so that we will use the list of keys to make those optional. And then we can join the optional section and non-optional section back. So I know this sounds like pretty confusing. So let's see it in action. So step 1, create our optional type. We already did that. So moving on to step 2, we can unbox the optional type. So I'm using a generic here, which basically just extract it using infer. And now we're getting a plain item. And by doing this, we can see that every field that's marked as optional now can be unboxed. And it's now just become like a type of string. But every type that's not optional just becomes never. And it makes it easy to check for that later. Okay, step 3. Now it's time to check for an optional keys. So now by using this filter keys generic, what we can do is we can filter out those. For example, a tagline and age exists and it's not never. So we know that it's an optional. So we can use this filter key generic to just get a union of what should be optional. So we can pass it to nullable partial. And that's exactly what to do next. So I can use this nullable partial generic. And then I use those two values, which is the optional fields and the optional keys. And then I pass that to nullable partial. And now we can see that they got like the question mark, which means now they're optional. And I know this is like pretty overcomplicated, and there's definitely a better way to do this. But this is more like a practice to like deal with a lot of generic types. And finally, we can just join the optional and the non-optional types. And now we can see we get what we want. Now only the name is required, and the age and the tagline is now optional, which is precisely what we want. Also, the extract and the exclude type is my most favorite. Since those, so basically what they do is they allows you to exclude a partial, maybe exclude a partial, not partial, I mean a particular union member from the list of unions. So that really helps a lot. And we're almost done here, yay. And finally, about the talk title. So you can see what I have spoken now has to do with advanced types. So what does the talk title mean? So this is what I mean. You might not really need advanced types if you can simplify your API surface. And so what I mean by this is the first time I did this schema builder, I did it with classes first. And by doing it with classes, I ran into a lot of difficulties, having to use new type. So the complexity of your type kind of depends on how you design your API. So my recommendation is to type your API first and then implement it later. because most people that is like a newcomer to TypeScript, they usually just like write the code first and then try to type it later. And that's not going to scale. And yeah, so maybe like a train of thought, maybe it might be even better if the end user just wrote their own types. Maybe that will get rid of the complexity. And it really depends. So I'm going to end with a closing note. And thank you everyone for listening. And if you have like any questions, please feel free to ask me. And I will post like the code to GitHub so you can try it in your playground. Thank you.
Boom! Thank you so much for that. That was really, it's always great to see like more and more talks going into deeper topics with TypeScript, but also it seems like one of the common problems that continuously comes back is this relationship between validation, runtime validation, and the type system, build time, type safety essentially. And so this solution that you came up with was essentially an API that allows you to generate both JSON schema, which you can use for runtime validation, and generate types using the generic, basically the type system, to generate these types that you can use. And that was really cool to see. So thank you for that.
Thank you. Oh, sorry, I forgot to mention one thing. Yeah,
Sure.
so one more thing. Yeah, so Brickle is actually hiring, and we're looking for like software engineers, like both in back end and in front end. And like the problems I show you today was actually like from one of my production work. So if you like to deal with this like TypeScript advanced types, then feel free to join us. That's it. Thank you.
Cool. Are you ready for some questions? Let's see if we have anyone.
Yep, sure.
Okay. Let's see, anything in the comments? Well, we have a lot of positive sentiment from the crowd. So thank you for everyone who joined. And if there are no questions, we will now go to the quiz part. So I will share my screen for that and update the banner. Okay, cool. So the last question we had was from the previous talk, and now I will advance this to the questions for this talk. So first of all, the leader of the first place in the leaderboard is right now Simon Knott. So let's see if anyone overtakes him. And you should note that the quicker you respond, the higher the ranking. And so, what does the exclude utility type do? And we already have one vote in. Let's see. So we got 19 votes for the previous question. So let's see. Yes. Benny, I will give a countdown. All right, you have 10 more seconds to get your vote in. Okay, and we are going to finish now. And so most chose the second option, exclude the given union members from the type. And let's see what the result was. And indeed, that was the correct one. So Simon is still leading. Let's see, we still have more questions. And now we have the second question for this talk. Which keyword do you use to extract a type contained or wrapped inside of a generic? Poom, someone asked if you could share a link to the GitHub code.
Oh, sure. I haven't like put the code at GitHub yet. I will do it after the talk. Yeah, so you can monitor my GitHub profile.
Cool. All right, you have 10 more seconds. And I'm about to close it. Get your vote in. Okay. So most chose the third option, and that is infer. And let's see. And indeed, that was the correct answer. Okay, so let's look at the leaderboard once again. Okay. So we have George who's leading, and it looks like it might be George who will win, but there's still many more questions. So now we get to the 5th question of the quiz. How do we construct a read-only string from a list of strings without the use of asConst? So we had a question from the audience, from Guy S, who asked, do you use OpenGI in Brickle?
Well, yes, we actually use WebGL, and our main technology is on Tree.js and Fabric.js. So yeah, we use like a lot of 3D technologies.
Cool. Thank you for that question, Guy. Okay, we have 14 votes, 10 more seconds to go. Okay, let's look at the results. So by the use of the reader-only read-only keyword, and most of you got it wrong by the use of REST operator in a function argument. Okay, let's look at the leaderboard. All right, so we have Sumya Geeky SRM who's leading right now. And I believe that we have one more question from you. No, I think that was the last question. Okay, so on that note, Poom, once again, thank you for your talk. Hope to see you soon at another TypeScript meetup. And in the meanwhile, stay safe and take care.
Thank you so much. สวัสดีครับ บ๊ายบาย
ครับ Okay, we are now coming up with the 3rd talk of today's meetup, and we have a very, very special guest who's joining us from Potsdam in Berlin. And so we have Simon Knott joining us, and I'll bring him onto the stage. Hello, welcome. Let me just get the labels working. Okay, so Simon, welcome. It's nice
Thanks
to
for
have you
having me.
here.
Yeah.
So I'll give a short introduction, and then hopefully we can get started with your talk. So I'll also bring your slides onto the screen. So Simon Knott is a maintainer at Blitz.js. He implemented SuperJSON and currently builds Quirl, a task queuing solution for serverless deployments. He also created Ent-E, a digital absence accounting solution for German schools. And when he's not working on development tooling, he loves riding his bike and DJing. And sometimes he's also found studying at Hasso-Plattner Institut in Potsdam. So Simon, your talk for today is fully typed full stack development using Blitz.js. And without any further delay, I'm going to give you the stage.
Right. Thanks, Daniel. Yeah, as Daniel said, in my talk, we're going to have a look at fully typed full stack development. And it's going to be 2 parts. So at first, we're going to take a look at Blitz.js and especially one aspect of it. Then we're going to take a step back and have a look at whether we can spot a trend in the web development ecosystem from what we've seen in Blitz.js. So I've got a slide that tells you who I am, but Daniel already did that, so we're going to skip it. Let's just get right into what's Blitz.js. I guess most of you haven't heard of it. Blitz.js describes itself as the full stack React framework. So it's a framework used to create React web applications, as opposed to, say, web pages. And it's built on Next.js, which is that awesome React framework by the team at Vercel, and takes heavy inspiration by the mother of productivity, by Ruby on Rails. The main value proposition of Blitz is that it makes you hella productive. It really supercharges your productivity, and I can personally vouch for that. And one of the ways it does that is by the so-called zero API data layer. And that's what we're going to take a look at today. So first thing, we're going to need to install Blitz. Similar is easy, just run npm install global blitz, and then you got the Blitz command line interface. and then you can use Blitz new and then the name of your project to scaffold a new baby Blitz project. In this case, we're going to build the TS Meetup page. So this is a page for this meetup here, where the upcoming meetups can be seen, and people can like say, well, I'll participate there, and just like a simple demo app. So run Blitz new TS Meetup page to generate that, and then change into that directory and run Blitz start to start your development environment. And now, again, what we want to build is that meetup page, and the first thing we're going to need is a page or a route called /meetups, where you can see the upcoming ones. And to implement that, we're going to create a new file, which is at pages/meetups.tsx. That is just like a Next.js convention. Whatever file is placed in the pages folder will become a new route in your application. So that file will be accessible at /meetups. And it's a very simple React component. You don't need to understand React for this talk at all. Just know that this function, it fetches the upcoming meetups from, say, your database, and then it renders them in some list. But the question is, how does it fetch the upcoming meetups? How does it do that? And back in your olden days, when we had like server-side rendering, maybe with PHP or like anything that's older than a couple of years, that was easy. Everything is rendered on the server, so just call your database. You got access there anyways. But now, recently, client-side rendering has become quite a rage, and you'd also want to get the new meetups or get the upcoming meetups from the client side. And so now, like, it's kind of obvious that you don't want to access the full database from the client side. So how do you get the data? And you may, like, the obvious solution to that is, well, just create some API that the front end can call. But just create some API, like, there's so many choices. There, you can create a REST API, you can use JSON, but you can also have like in GraphQL endpoints. You can use good old RPC, but like if you use GraphQL, do you use Apollo or Relay? Maybe you don't have an API at all, but put your data into like some user accessible database like FaunaDB or Firestore. And even when you have that, like you just use REST, how do you fetch the data on the front end? Do you just use like Window or Fetch? Do you use some accompanying tools like React Query or something? Like there is a lot of different choices available. And to be honest, it doesn't really matter what you decide to use. Whether you use REST or GraphQL or something like this, well, it matters from a development kind of standpoint. Because it impacts the way you work and it impacts the development speed you can work at. But it wants, like, there's no user coming to you and saying, I love that you use GraphQL at Facebook because it makes my pages super fast. Like, your users won't worry about or won't care about the underlying technologies. And to be honest, this is just a lot of different choices and a lot of headache caused by what kind of transport you use. And this is also not easy. You still have to do like a lot of thinking about what would be the right solution. And even when you decided for something, let's say you're going to build a REST API, you always have to decide what's the right name for the routes. Do I use get, put, post, patch, options, head, make call, or what do you use as HTTP headers? How do my HTTP headers work? And so how would this look like if it were easy? That's the question that Brandon Bayer, who's the original author or the original creator of Blitz.js, that's the question he asked to himself. Like, if this were as easy as possible, how would this look like? And to be honest, if this were as easy as possible, you just import your backend function from the front end and call it like any other function. you wouldn't want to worry about transferring the data over the network. And that's actually what's possible with Blitz.js. That's the so-called zero API data layer. So let's get back to our page. And as you can see in the second line, we import a function called getMeetups from queries/getMeetups. And that is actually a function that when run or when called will execute on the backend. It doesn't matter if you call it from the backend or from the front end, it will execute on the backend. So it has full access to the database and like to the full node.js APIs. And you import that, and then in the first row of or in the first line of the component, you can just call getMeetups. And that's how it works. At least conceptually. Like in reality, you still have to import like some helpers from Blitz, like use query, and then you're gonna have to wrap it in use query. But that's just to make TypeScript types work. And all of the rest, it's like, it works. So yeah, you get the concept. And to show you like this is not some weird trickery with the queries and getMeetups thing. If we have a look at that getMeetups file, this is queries/getMeetups. This is just normal TypeScript code, right? There's this function called getMeetups that like uses the database client to find like the upcoming meetups, and then it just returns it, and then that function is exported as default. And that's all. Like that's the function that's imported here, and it works. And actually, that import db from db that you see there, db is actually just an alias in Blitz. It's the default alias on Blitz.js for a Prisma client. So we're going to take a look at Prisma, who you may know because they're the organizers of this meetup. We're going to take a look at that later. All right, and because this is just normal TypeScript code, there is full TypeScript support. Here's a screenshot from VS Code where you can see how this fully supports like full editor integration and full autocomplete, because the code is just like you just import a function and you call it, and actually those two auto suggestions you can see there, these come from the database client, so they're fully passed through. And that is something that doesn't happen with with traditional backends and or with traditional API styles of things. And that's because like normally the type soundness of even for TypeScript projects, it's lost in transit when transiting over the network. So when I first saw this, I was like, wow, this is amazing. Like it's just so easy, and you don't have to worry about all those things. And now if you're like, oh, if you're like me and you're like, wow, I need to check this out, like really go check it out. Blitz started at the beginning of this year, and it's been around 145 contributors since then. We started at the beginning of the year, and we're about to hit beta in the coming days and plan on moving to version 1.0 by the end of the year. There's already some production Blitz apps out in the wild. For example, the Quirrell landing page is built in Blitz, and like I can vouch for it, and it makes you very productive. Okay, so let's get back to that magic trickery with importing the backend. And I can see that in the chat you're already debating about how this works technically. And I think, let's see. Yep, it seems like you're kind of correct. So let me tell you how that works. You can see here that there is this import from queries/getMeetups. And whenever you import a file from a folder that is called queries, so queries is a magical name in this context. Whenever you import a file from a folder called queries, or mutations for that matter, we will take that import and replace it with a function that calls the backend to execute that import. Again, so whenever you import from there, we're going to replace it in a compile step. We're going to replace it with a function that calls the backend. So we generate the API for you. That's why it's called the zero API data layer. For you as a user, you don't have to worry about APIs, or for you as a developer. API is none of your business, or at least nothing you need to worry about or think about. And then the API is auto-generated for you. And depending on queries or mutations, we do some things differently to have it work well with caching and stuff, but the concept is the same. And that concept can be called code generation. Code generation is the process of taking some artifact, for example code, and transforming it into code. And that is actually a thing that Blitz uses to make developer experience so good. And Blitz is not the only thing to use code generation. Another tool that uses code generation heavily is Prisma. I promise we're going to take a look at Prisma, and that's what we're going to do now. So Prisma is that database client by that nice company who organized this meeting. And it works like the following. So you specify your schema, your Prisma schema. In Blitz apps, it's at db/schema.prisma. And that Prisma schema is a file where you put in your data model for your application. This is in like a Prisma specific language, and you can see like there's two models, one for Meetup and one for participants, and both have like an ID and a name. Meetups have a date, and then there's like a many-to-many relationship between those two. And you take that model, and then you run Prisma generate, or Blitz.db migrate for that matter. Blitz encapsulates it. And when you run that, Prisma takes your artifact, which is the Prisma schema. It does some transformations, and it generates this code for you. So this is the generated code. Again, code generation. So it takes the schema, and for example, it makes this type out of it, the Meetup type with like an ID and a name and some other properties. And it also generates the Meetup delegate, which is an interface that contains like data access or database access functions. That it has like a find one function where you can find exactly one, or I think now it's called find first, where you can find one row in the database, has like an update, a delete function, all that good stuff. And it even has like custom-made comments. So this is really like next level developer experience, because this is normal TypeScript code. Your VS Code can fully give you editor support. That's what we've seen a couple slides back. And the interesting thing about Prisma is it generates into your node modules folder. So this file lies at node modules/.prisma/client. So this is also code generation. And turns out code generation is used in Blitz and in Prisma, but not only there, but also in these well-known things. Let's start from the top. Babel. I guess you haven't heard about Babel. Babel is like the mother of code generation, or the mother of code transformation. Babel takes modern JavaScript like ES-Next, ES7, or are we at ES9 yet? I don't know. So you take like a modern JavaScript version and you do some transformations to transform it into an old JavaScript version like ES3 that even Internet Explorer can understand. And you can also do like custom modifications, which is the very interesting thing about Babel. It's pluggable, so you can have, for example, your own Babel plugin that, as an example, I created a Babel plugin that for Next.js and SuperJSON users that wraps all of your Next.js routes to use SuperJSON by default without the developers to do anything. That's what you can use Babel for. So Take modern JavaScript, make old JavaScript out of it. Then there's Tailwind CSS. Tailwind is a lot more akin to something like Prisma. You take your Tailwind config, where there's colors in there and like custom gapping sizes and paddings and all that stuff. And then it generates your own tailor-made custom CSS framework for you. There's stuff like Sass, which is basically the TypeScript of CSS, which lets you write CSS at a higher level, and then Sass comes in and compiles that back to CSS. So take Sass code and generate CSS code out of it. Again, code generation. And then stuff like Next.js. In Next.js, your artifact that you put in is the file-based routing structure. So any file in the pages directory is a route. Then Next.js does some transformations and some generation steps to generate an arguably more complex version of your app that fully supports server-side rendering, client-side routing, and all of the data fetching method that Next.js offers. This is also code generation. And there's a lot more examples like Webpack, or even the JSON schema to TypeScript package that Ethan talked about, which is also great, which takes JSON schema files and then transforms it to TypeScript, also code generation. All right, but it's awesome, but it has its problems. And the biggest problem, at least for me, is fragmentation, which seems to be kind of an overarching problem of the JavaScript ecosystem, I guess. But the thing is that there is no agreed upon way to do code generation. Everybody builds their own toolchain. And TypeScript has their fully own parser, let alone their parser is 8,000 lines. Then there's Babel, which uses a modification of Econ for their parser, or Webpack, which uses normal Econ, and then a lot of other things. Like Blitz has its own, Next has its own. They all do their own kind of tool chain. And this comes with performance issues, because building a code generation toolchain is, in a lot of ways, very akin to building a compiler. And we all know building a compiler is hard. So yeah, performance issues. Also, limited portability. So you can't just take your Babel plugin and move it to, say, Webpack, which makes it hard to move to new projects, move to new tools in your toolchain. Which brings me to the next problem. There's no agreed upon standard to do code generation anyway. So some projects generate into node modules, like Prisma does. Then there's stuff like JSON schema to TypeScript that generates into your source directory and then kindly asks you to add their files to the git ignore. There is stuff like Tailwind, which generates its output code into some hidden away pipeline thingy so that the bundler can use it, and a lot of different ways. And this also results in poor editor integration because there's no agreed upon standard. No editor can accompany to that. And the only way that the awesome editor support of Prisma can work is because it generates real files, files in your file system. And that has its problems too. Apart from that, there's user-generated files in node modules, which, to be honest, shouldn't belong there. There's the problem of people forgetting about regenerating their TypeScript regenerating their Prisma client, which I am suspect to as well. I do it all the time. I always change my model and forget to regenerate the client. And also having no standard just makes it hard to build additional tooling on top of it. So it would be better to have an official JavaScript standard, or at least something like an industry standard. And in the Java ecosystem, this is something that's been there for quite a time, right? 16 years now, since the annotation processing API has been introduced. And annotation processing is actually something where Java code can hook into the compilation process, and it's used in it's in wide use across the Java ecosystem. So you may have heard of Project Lombok or of Spring Boot. Both of them make heavy use of annotation processing, and I'd say that most JavaScript frameworks use it. Also, C# has introduced support for source generators earlier this year. So yeah, that's also something where people are taking a look at code generation. So let's see how we could fix this problem in the JavaScript ecosystem. And to see how that could work, let's have a look at a conceptual view of our current tooling. So this is a conceptual view of Babel. Remember the tool that takes like modern JavaScript code and turns it into old JavaScript code. So it takes some source code, like modern JavaScript code, and then it lexes and parses it. So lexing and parsing is like the technical term for making sense of your code and building like a so-called abstract syntax tree, which is like a representation of your program. And then after it lexed and parsed it, it will put that into the transform step. And the transform step in Babel is called plugins. And so a plugin is a function that takes the abstract syntax tree, the code, does some transformations and returns it. So these plugins are what allow to take modern JavaScript code and transform it. And there can be potentially like a lot of plugins, and you can even use your own custom ones. And then after you transformed it and you have like your final output, you take that abstract syntax tree and use it to generate output. All right. Then there is this conceptual view of TypeScript. So in TypeScript, you also take some source code, and in this example, you take TypeScript code, then you lex and parse it, and then that's the interesting thing about TypeScript. You check types. You've got that type system, and you do some type soundness checking and stuff like that. And then conceptually, that's the point where the editor integration happens after checking types, so that your editor knows whether the types are correct or not. And then after we check types, we're going to again transform it. This time, this transformation step is not user pluggable, but it depends on what your TypeScript config says. So when your deployment target is like ES3 or ES5 or something like that, it will transform a lot, like to ES3 or ES5, but if it's like ES next, it will only like strip away the types. And then it again takes and generates output, very similar. So what would it look like if Babel and TypeScript joined forces? If TypeScript would become better when it comes to code generation. Because like we've seen, Babel does code generation well and TypeScript does not, so okay. So this is how it could look like if they joined forces. Again, take source code, this time not only JavaScript and TypeScript, but also JSON, Prisma schema files, Tailwind configs, and potentially even like images or something, any file. You again lex and parse it, and then you pass it to this pre-type checking transformation step. So this is similar to the transform step in Babel, as in it's user configurable, it's pluggable. And in this step, that's where our code generation happens. This is where, for example, Prisma is, and Prisma picks the incoming Prisma schema file and then generates outgoing like its Prisma client and gives that back into the pipeline, so that when the transforming is done, check types will have access to all of the generated files that have been generated by the Prisma compile plugin. And for JSON schema to TypeScript, this would be even easier. So what you could do is you could take some JSON file and transform it to TypeScript files, and then in check types you could just you could not have to import from a different file, but in your TypeScript code you could just import a JSON and it would export some type. And because the editor integration would happen here, it would work wonderful for developers. All right, and then after checking types, we again transform, this time like similar to in the TypeScript step, transform to the target platform, ES3, ES5, anything you'd like, WebAssembly potentially, then generate the output. All right, so this is nothing that like I know the TypeScript team to be working off. This is just my own weird thoughts. I'd love to see something like this. And I think it would be useful to the community because it would greatly simplify the process of code generation and thus make developer experience a lot better in the process. But this is not the only idea. I've got an excerpt from the blog post on introducing Rome here by Sebastian McKenzie. And Sebastian McKenzie is kind of a well-known name because he's the one that developed the original version of Babel. So the Babel plugin, or the Babel project that pretty much powers all of our JavaScript toolchains at the moment, except when it's using TypeScript. That's the guy who worked on it. And in this blog post, which is a couple of days old, I think, or like a couple of weeks, he says, language tooling maintainers spend so much time working on the same things, but processing source code, whether it's in a transpiler like Babel, linting it in ESLint, or bundling it in Webpack, is fundamentally the same problem, with overlapping responsibilities and technical implementation. A linter in the JavaScript ecosystem is exactly the same as a compiler. They both consume code, then produce compiled code and errors. So that's what he says about like the current state of JavaScript tooling. Basically, he says we all do the same and we work on our own projects. Why not join forces and all work on one project instead? And that's what he's doing. So Rome is the project he currently works at, which is meant as kind of like a spiritual successor to Babel. And it's kind of a unified tool. It does linting, bundling, compiling, type checking, and all of that stuff for you in one package. And thus it wants to be like more efficient and like just a better experience. And that's what he's currently working on. I think it's financed by Facebook, not sure. Yeah, but that could also be the solution to the code generation problem. Like if Rome had a user pluggable code generation step, that would solve the problem. We'd only need Rome to have like support for the language server protocol then, and that would be it. All right, so that's what Seb has to say. All right, we're coming towards the end of the talk. Let's do a quick recap on this. So in the first half of the talk, we've seen Blitz.js, or at least parts of Blitz.js. Blitz.js is a full-stack React framework. It has awesome developer experience, at least from what I'm concerned, and it's a community-maintained project. You should definitely check it out. Like I say that really like in deep love for Blitz.js. It's awesome, and really come by at our Slack. We're very welcoming, very inclusive, and overall nice community of people helping each other and like sharing a common goal of good JavaScript or good React future, good React tooling. All right. Blitz.js uses code generation under the hood, just as a lot of other tools. Code generation has become more and more relevant in the recent years, especially in the JavaScript ecosystem. It has been kind of a normal thing in other ecosystems, but in JavaScript it has become more and more relevant. It can be used to supercharge developer experience, for example, in Blitz or in Prisma. And it's a huge driver behind the really recent tooling improvements that we've seen. Still, there's some room for improvement in code generation, and I'm looking forward to see what will be there in the future. Okay. I originally had like a shameless plug for Quirrell in this slide, but given how often Daniel has talked about Quirrell, I think we'll just skip this now. And now I gotta say, like, that's all, folks. That's been my talk. And now I'm looking forward to questions from you.
Sorry, my microphone was on mute. So thank you so much for that talk. That was really insightful.
Yeah,
I think
you're
that was a
welcome.
really
Thank
good
you.
introduction to Blitz and also to a lot of the shifts that we're seeing in the JavaScript and TypeScript ecosystem at large. So exciting things, and indeed now is the time for questions. So if you're listening and if you viewed the talk and you have questions, now is the time to drop your questions in the chat. Thank you for the comment. And if there are no questions, I think we can go on to the quiz before we wrap up for today. Okay, let's get on with the quiz. So we have some really positive feedback. I think
Thank
one of
you.
the nice things that I've noticed is that, we have one from Emma. Amazing framework. Haven't heard about it before. It looks promising. Is it production ready?
Yeah, that's an interesting question, actually, because what I would tell you, like, from an emotional kind of standpoint is different what like the rational Simon would tell you. So if production ready really means for like your big project where you earn tons of money, no, it's not. It is currently still in alpha. I think I forgot to mention that. Currently it's still in alpha, and we're moving to beta in the next couple of days, actually, and aiming to go to 1.0 by the end of the year. However, I am currently using Blitz, and I know a lot of other people are already using Blitz in their own projects, also in production. So, for example, the Quirrell landing page and the Quirrell dashboard, which is the place where you can like put in your payment details and get like Quirrell API keys and then see like statistics. That is fully developed using Blitz, and it really made me productive. And then there's also some other like smaller tools that have been developed using Blitz. So, for example, a couple of days ago there was the React Summit conference. You may have heard of that. And they had like some conference badge application that we actually found out was built using Blitz. And at the moment, that's like the prime thing, because it's it's not that important. But the cool thing about Blitz is it makes you super productive, also on these more fun projects. So yeah. Is it production ready? Kind of depends. So for me, it is for my own projects, but I'm also level 2 maintainer, and whenever there's a problem, I mostly can get it fixed myself and provide a bug. For other things, I don't know. But if you're interested, definitely check by at the Slack, and people will answer you all your questions you have.
So we had another question coming in from George, and I guess this is also touching on probably one of the biggest value propositions of Blitz, and that is that there is no, it sort of like abstracts the API layer for you. And so George is asking, how flexible, configurable, or pluggable is the transport layer?
So I'm not sure if I fully understood that question, because the way I see it, the the value proposition of Blitz is that it abstracts away that transport layer. So making it configurable is not really something we're interested to do. We're interested in providing like the one solution that does everything. There may be things that like I'm not really sure what you mean by that. If it's stuff like I have my own data types that I want to be transferred correctly, that's something we've got figured out. So Dan has mentioned that I am the code owner for SuperJSON, which is Blitz's own JSON serialization framework. So it basically takes some JSON and generates another JSON out of it. So again, code generation basically, but this time in runtime. Generates another JSON out of it and adds some annotations on what the original types were, so that when we transfer it over the wire, we can then like reapply those annotations to preserve the types of things. Because so maybe you know that when you JSON.stringify a date object, it will be downgraded to a string, but with SuperJSON it won't. So it will be downgraded to a string and then get that annotation attached, and then afterwards we just reapply that annotation to make a string out of it. That's something we do in the transport layer that may be interesting to you.
All right, and now I think is the time. We had one last question. Maybe you can sort of give a short answer to that. Is there an example of a mid-size or large size application built on Blitz?
Well, large size, I don't think so. Mid-size, maybe check out the Quirrell webpage, which is open sourced, or take a look at the Blitz wiki. There is a list of apps that are in production running Blitz, and there's something like a Blitz-based job board and some like startup landing pages and startup applications that could be considered mid-size, I think.
All right. Well, now I think we're going to finish up with the quiz.
Yeah.
George did have a reply, but I encourage you to take this and continue this conversation. I'm also interested
George,
to hear.
Just message me on Twitter and we'll talk afterwards.
Great. So now we'll bring back up the last part of the quiz for which we have an award. So we have Sumya who's leading the leaderboard, and we have 2 more questions. And so we will now move on to these last 2 questions. And so we have the question, who is the original author of Babel? Okay, we have 2 votes already in, 3 votes. Some very interesting choices there.
What do you mean, like Douglas Adams?
Yeah.
Yeah, but because like the Babel fish.
Right. Okay, 10 more seconds and we're going to close the vote. Okay, we have 1 more coming in. And we're going to wrap it up. Okay, let's see. So indeed, it's Seb McKenzie. And we have Sumya, who's still in the first place. And now we're moving on to the last question. And so the last question is, what is the name of Blitz's original creator? Five votes. We'll give it 10 more seconds. Enough time to Google it. All right. And we're going to wrap it up. And the voting is closed. So indeed, it's Brandon.
That's kind of a good result.
Yes, so we have a winner. Sumya Geeky SRM. So congratulations, you won a lifetime subscription to Quirrell, the serverless queue manager, and also a lot of Prisma swag. We'll send you a t-shirt and all of the other goodies. I suggest that you reach out to me via Twitter, and so that I can get your address and everything. And so on that note, I'd also like to thank you, Simon, for your insightful talk. That was a really introduction to Blitz.
Thanks for having me.
And do you have anything else to share before we wrap up?
No, I think it was a nice evening here.
Cool.
Yeah.
So thank you so much, Simon. Enjoy the rest of your evening.
Yeah, thank you. You too.
Okay, so we now come to the last part of today's event. And for that, I'd like to announce that we also have a new meetup that we're starting. And that is, I'm going to share my screen once again. But the name is going to be called Advanced TypeScript Trickery. So let me just share my screen here. So the meetup, you can join it. I'll drop a link in the chat. And the idea is that this meetup will be a bit of a smaller meetup, and it will happen on Zoom. And the idea is to create like a gathering around like a virtual fire to chat about some advanced TypeScript stuff. And so this will be moderated by Tim Sochanek. Some of you may know Tim Sochanek. He's a software engineer at Prisma, and he's leading a lot of the TypeScript efforts. He also gave talks at TSConf recently, and he's been very active with the TypeScript community at large. So I think these will be really exciting, and if you're interested, you can join the meetup group. And all of these talks will also be published on YouTube after. So you'll be able to access them, and they'll also be transcribed, so they'll be accessible. So on that note, we had about 70, I think at the peak we had 80 viewers tonight, or today, depending on where you're joining from. Okay, I'll open up my DMs. I thought I had DMs open, but I'll open them up in a second, and you should be able to send me your email. And yes, so thank you so much for joining. Thank you to the speakers. That was really great. And hope to see you here again for the next TypeScript meetup. So goodbye.